Alright, this is lesson 75, and I am on page 305 of your textbook, and it is writing equation of a line using slope-intercept form and using slope-intercept form for graphing. Alright, so first of all, we're going to learn how to write the equation of a straight line. So on the example A, we have a line that looks like that, and then B is a line that's over here, right there, and then C is some horizontal lines, and then D is another horizontal line right there. Alright, so A is the black one. Alright, so when we have vertical and horizontal lines, the formula for those are really, really easy. We're going to say that on this one we have to move on our x-axis. Remember, this side's x, and then up and down is y. So on our x, we had to go back 1, 2, 3. So the formula for this black one is x equals -3. We don't have to tell what y equals, because no matter what, x is always going to be -3 no matter what y is. Alright, so for our other one, our purple one, it's on B. This one we moved on our x-axis. We moved 1, 2, 3, 4, 5. So this is going to be called x equals 5. Okay, let's try our our horizontal lines. This green one, we didn't move the x-axis. We're not concerned with. We're concerned with the y. 1, 2. So we had to go up 2 on our y. So we're going to call that one y equals 2, no matter what x is. And then our last one, the red one, D, we had to go on our y-axis down 1, 2, 3, 4. So that one's called y equals -4. So writing the formula for vertical and horizontal straight lines is pretty easy. If it is a horizontal line going with a horizon, it's going to be a y equals whatever it is. And then if it's a vertical line going up and down, it's going to be x equals whatever it is. Alright, the next part is going to be about slanted lines, lines that aren't straight. They have a slant to them, and in math we call a slant a slope. Alright, so for slope is going to be a number represented by rise over run. Rise is how much we're going up and down. That's our change in y-axis. And our run is how much we're going back and forth. So that's going to be our change in x-axis. So how much do we change from one point to another on our x, and how much do we change on our y? Alright, to give you an example of that, I will draw a line and figure out the slope for it. Let me get a good one going here. Okay, so on this line, remember, it's rise over run. Alright, so the rise is going to tell us how much we changed in y-axis, how much we went up and down, and the run is going to tell us how far we went back and forth on our x-axis. So let's pick two places where it's touching. So right here it's touching lines, and then right here it's touching. Alright, so we went down 1, 2, 3, so -3. is our rise. And our run, we went over 1, 2. So we went over 2. So the slope of this line is negative 3 over 2. All right, let's make another line. I'm going to just make one down here. Okay, so for this one, we can pick any 2 points right here and right here, let's say. All right, so for this one, I had to go up 2. So that will be our first part, how much we went up and down, our rise. And now our run, we went over 1. So we went up 2 over 1. So that is a slope of 2 over 1, which would just reduce to 2. So the slope of that line is 2. Now you'll notice that if your line is going uphill, see how this one goes uphill, that is a positive slope. And when your line's going downhill, that's going to be a negative slope. So we could also write that as negative 3 over 2. Alright, let me give you some more examples of slope. Alright, let's say that we had a slope of 1. If our slope is 1, that really means 1 over 1, because anytime we have a whole number, we can put it over 1 to make it a fraction. And that's going to be our rise over our run. So that means we go up 1 over 1. So if we start at 0, we go up 1 over 1 for all of these, and we end up with a slope that looks like that, which is basically just a diagonal line, a 45, cutting that in half between here and here. Alright, so what if we have a slope that is more than 1? What if we have a slope that's 2? So 2 would be 2 over 1, with 2 as our rise and 1 as our run. So that means we go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and our slope, our line would look like that. So that is a slope of 2. So the higher the number, the more it's going to get towards the up and down, the vertical. What if we have a fractional slope, something that's less than 1? So let's do a slope of 1/2. So that means rise is 1, our run is 2. So we go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And that is going to give us a line that looks like that, halfway in between there and there. Now, as our fraction gets smaller and smaller, so let's say 1/5, it's going to get closer to horizontal. So if we did up 1 over 5, 1, 2, 3, 4, 5, it would be here. Up 1 over 1, 2, 3, 4, 5, it would be there. So we end up with a line that is closer to horizontal. Alright, so that's slope. Alright, so what is slope-intercept form? Slope-intercept form is a way to write the formula for a line that lets us know easily what the slope is and what the y-intercept is. Now, the y-intercept is just where your line crosses the y-axis, where it crosses y. So let's start with y equals 1/2 plus 2. Y equals 1/2 plus 2. Now that is written in slope-intercept form. And slope-intercept form is whenever you write it in the form of y equals mx plus b. B is our y-intercept. And m is our slope. So if we have it written as y equals 2x, let's say, plus 3. Our slope is 2. Our y-intercept is 3. And that will allow us to graph this line without making a chart. So our y-intercept is 3. That just means that that is where it's going to cross that y line. So if our y-intercept is 3, we're just going to go on our y line and we're going to say 1, 2, 3 and make a dot. Now our slope is 2. If slope is rise over run, that's going to mean if our slope is 2, it's going to be 2 over 1. because we can always put a whole number over 1 to make it a fraction. So that means we're going to go up 2 over 1. So we start at our first dot, our y-intercept, and we go up 2 over 1. Up 2 over 1. Up 2 over 1. And that gives us a line that looks like that. Alright, let's try another one. Let's try y equals 3x minus 4. Okay, so if we write out y equals mx plus b, we can see that this plus right here will be our negative 4. So that's our y-intercept. 1, 2, 3, 4. So we're going to go down 4 on the y-line and make a dot. Now our m, our slope, would be 3. And that's really 3 over 1. And remember, rise over run. Our rise is 3, so we're going to go up 3. And our run is 1 over 1. Up 3 over 1. Up 3 over 1. Up 3 over 1. And that's as far as we can go. And then we draw our line. And you see how this is a positive slope. We're going uphill because this 3 is positive. Right, I'll do another one. Okay, we're going to do another example. This one we'll do y equals 3x plus 4. Alright, so if we write y equals mx plus b, we can see that our y-intercept is 4 and that our slope is 3. Alright, so a y-intercept of 4 means we're going to start at 0. We're going to count up 1, 2, 3, 4, and that's our first point. That's where it crosses the y-line. And then m is our slope right there. So our slope is 3, which really means 3 over 1, and slope is rise over run. That means we got to go up 3 over 1. 1, 2, 3 over 1 and make a dot. Go up 3 over 1 and make a dot. We can also go back 1, down 3, back 1, down 3. And this is a positive slope. It's positive 3, so that means we're going uphill. And there's the line. Alright, I'll do another example. Let's do y equals negative 2/3 plus 2. Alright, so if we could put y equals mx plus b, we can see that that is going to be our y-intercept is 2 because it's in the place of b. So we're going to count up 2 and put a dot. And then we see our slope, m is our slope. So that is negative 2/3. So slope is negative 2 over 3. The top number is our rise over run. And it's negative 2. Now we could say negative 2. So that means our rise is negative 2. So we have to go down 2 and over 3. Down 2 over 3. Or we could say our negative is down here. So we will go up 2, backwards 3. Either way, we're going to still be on the same line. Up 2, backwards 3. And there's our line. Alright, we'll try another one with a negative slope. Negative slope means we're going downhill. Positive slope means we're going uphill. Like if we went from left to right. Let's try y equals negative 1/2 x minus 3. Okay, minus 3. Here's our y-intercept, and then that's our slope. Because whatever one's next to x is going to be the slope, and then whatever is added or subtracted is our y-intercept. Alright, so negative 3 means we're going to start at 0, and we're going to go down 3. 1, 2, 3. Negative 1/2 is our rise over run. So that means we got to go down 1 over 2, down 1 over 2, down 1 over 2. Or we could put the negative down here and we could say up 1, backwards 2, up 1, backwards 2, up 1, backwards 2. And that's going to give us our line. All right, they have a few more that are a little bit more confusing because they don't have them set up in slope-intercept form, so you have to change the form of the equation. So let's try 2y equals negative x plus 2. Okay, so we need this to be in y equals mx plus b form. And it doesn't look like that. So what we need is y by itself, then something multiplied times x, and then our slope. So to do that, we're going to have to divide everything by 2. Because we want to get y by itself. So 2 divided by 2 would be 1, so we get y by itself. Alright, so x divided by 2. That really means 1x divided by 2, which would be 1/2 x. So we get negative 1/2 x plus 2 divided by 2 is 1. So now it's in y equals mx plus b. We can see that our intercept, our y-intercept is 1. And m, our slope, is 1/2. Negative 1/2. Alright, so y-intercept 1, that means right there. And then 1/2, that's going to be our rise is 1, our run is 2. But it's negative, so we're going to go down 1 over 2, down 1 over 2, down 1 over 2. Or we could go up 1, backwards 2. And there's our line. Like that. Alright, we'll try another one that we have to rearrange. Let's try let's see. Y minus 2x equals 1. Get a new marker. Y minus 2x equals 1. Okay, so we got to get y by itself on the equal sign here. So we got to get rid of this minus 2x. We're going to say plus 2x plus 2x. These cancel. And we end up with y equals 2x plus 1. That wasn't that hard. So all we did was rearrange the equation. Alright, so now it's in y equals mx plus b. And we can see that 1 is our y-intercept. And then our slope is positive 2. And that really means 2 over 1, rise over run. So our rise is 2 and our run is 1. Up 2 over 1, up 2 over 1, up 2 over 1. Let's see. Backwards 2, down 1. There we go. And there is our line. Alright, so some of them you have to rearrange the equation to make sure that it's in the right form so that you can see what your y-intercept and your slope is. Let's try another one. Two y minus x. 2y equals negative x. I think I already did that one. Let's try y equals negative 1/3 plus 3. 1/3 x plus 3. Alright. That means we're just going to go here because that's our y-intercept. And negative 1/3 is our slope. So that means our rise would be go down 1 over 3, down 1 over 3, down 1 over 3. And there's our line. Whoops. I did not go on the line at all. There we go. We didn't have to rearrange that one. That one was already in the right form. All right, let's try 2x plus y plus 2 equals 0. All right, 2x plus y equals 0. Let's try that. Okay, so we got to get y by itself. So we're going to move this 2x over to this side of the equation. And we're going to get y equals negative 2x plus 0. Now, if you have one that says plus 0, that means that our first dot, our y-intercept, is going to be on 0. So they could have just left that off, and we wouldn't have a y-intercept. That means our y-intercept is on 0, the origin, 0, 0. All right, so then we got negative 2 is going to be our slope, and that's negative 2 over 1. Our rise is negative 2, so we go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And there's our line. Okay, so another type of problem that it may give you is going to give you a line and ask you to write an equation for that line. Alright, so if we know the y-intercept form of the equation, which is y equals mx plus b, we can find the equation for this line pretty easily. We need to find out m and we need to find out b. M is our slope, so we can just see where it crosses two lines, here and then here and then here. And we know that this is a positive slope because it's going uphill. Slope is rise over run. And our rise, we went up 1. So to travel from there to there, we had to go up 1 and over 2. So up 1 is our rise, over 2 is our run. So we know our slope is 1/2. So we can say y equals 1/2 x. We replaced m with 1/2, our slope, plus b. Now what's b? B is our y-intercept. That's where it crosses the y line, right there. And that is at negative 2. So we're going to say minus 2. So that is the equation for this red line. Y equals 1/2 x minus 2. 1/2 being our slope, negative 2 being our y-intercept. All right, I'm going to do the green line now. So that's going to be y equals mx plus b. We've got to find m and we've got to find b. M is our slope, and we just need to find 2 points where it touches intersecting lines, so right here. And a slope is rise over run. And our rise, we had to go up 1, 2, 3. So we went up 3. And then we went backwards 1, 2. So negative 2. We know this is a negative slope because we're going downhill. So y equals negative 3 over 2. Now we need our y-intercept. That's going to be b. So that's where it crosses the y line right there. And that's at 1, 2, 3. So positive 3 because we went up from 0 to 3. So the equation for the green line is y equals negative 3 over 2 plus 3. All right, pause the video and do the practice problems, and then we'll come back and I'll work them for you. Okay, here's the practice problems for lesson 75. And it asks you to find the equation of these lines. So, A, pretty easy. A, we moved on the y-axis. We went down. No matter what x is, y is always going to be negative 1, 2, 3. So, for A, the answer is y equals negative 3. Because we moved down on the y-axis. Alright, to find an equation for B, we can write y equals mx plus b. That's going to help us. M is our slope, so we would need to find that first. So let's find two places where they touch crossing lines there and there. And slope is rise over run. So we had to go up 1, backwards 3. And we can tell this is a negative slope because it's going downhill. So we're going to write y equals, and our slope is rise over run. So we went up 1, and it's negative, and backwards 2. Or we could say we went down 1, forwards 2. Either way is fine. Either way to think about it. Write that a little more clearly. Y equals negative 1/2 is our slope, x. Now we need to find our y-intercept. Here's 0. 1, 2, 3 is where it crosses. So plus 3. Y equals negative 1/2 x plus 3 is the answer for B on your practice problems. All right, C and D are right here. Now for C, we're moving over on the x-axis, and we went 1, 2, 3. So this one, C, is x. Well, that's not working. Let's do it with this pink one. C is x equals 3. It's pretty easy. We just moved over on the x 3 spaces. All right, D, I'm going to write y equals mx plus b. You're probably getting tired of hearing me say that, but it's really important that you memorize that. M is going to be our slope, and B is going to be our y-intercept. Figure out our slope. We know it's positive because it's going uphill. And we just find two places where it crosses. Let's see, right here and right here. We had to go up 1 over 2. We went up 1 over 2 to get to there. So rise over run, up 1 over 2. Plus B. B is going to be our y-intercept. So we, where it crosses the y line right here is 1, 2, 3. So it's plus 3. Y equals 1/2 plus 3. Oops, don't forget that x. Y equals 1/2 x plus 3. Okay, so that's it for lesson 75. And I'll join you shortly with lesson 76. Okay, lesson 76. And this is about consecutive integers. So the example problem 76.1 says find 3 consecutive integers such that the sum of the first and the third is 146. So we need 3 consecutive integers. The easiest way for you to keep track when you're doing these problems is you're going to write first, second, and third. Consecutive integers. Integers are just numbers, and consecutive means one after the other. So if our first consecutive integer was 1, our second would be 2, our third would be 3. If our first consecutive integer was 5, 6, and then 7. If the first one was 8, then it would be 9 and then 10. Consecutive means in a row, one right after the other. All right, so it's saying find 3 consecutive integers. Okay. And the way to do that is we're going to name the first consecutive integer x. The second consecutive integer will be x plus 1, whatever x is. So if x was 2, the next integer will be 2 plus 1, that would be 3. The next one would be x plus 2. So if this x is 2 plus 2, that would be 4. Does that make sense? Alright, so we're always going to set it up like this. We're going to write the first, the second, the third. The first is named x, the second is named x plus 1, the third is named x plus 2. And that gets us 3 consecutive integers. Alright, so then we have to make an equation out of that. So find 3 consecutive integers such that the sum of the first and the third, sum of the first and third is 146. So we're going to have to turn that into an equation. All right, sum tells us we're going to have to add the first and the third, and then that it's going to equal 146. So the first is x plus the third, so plus, and then the third is x plus 2 equals 146. Okay, so now we're going to combine like terms. X plus x is 2x plus 2 equals 146. Then we're going to subtract 2 on both sides. And we get 2x equals 144. And so then we're going to get, let's see, we're going to have to divide by 2. And x is going to equal let's see, 72. Let's see, 72 plus 72 for, yes. So if x equals 72, that's our first integer. So your answer is not going to be 72. You have to have 3 consecutive integers. That's what it's asking for. So you're going to have 72. 72 plus 1 is 73. And then the third is 72 plus 2, 74. 3 consecutive integers. All right, let's try another one. I'm going to use a different color. I like these colors. All right. Find 3 consecutive integers such that twice the sum of the first 2 is 2 less than 3 times the third. They are trying to make it super confusing, but it doesn't have to be. All right, so we're going to say first, second, third. Okay, so the first consecutive integer is going to be x. The second one is going to be x plus 1. And the third one is going to be x plus 2. Okay, so find 3 consecutive integers such that twice the sum of the first 2, twice sum of first 2 twice the sum of the first 2 is 2 less than 3 times the third. Okay, so that seems confusing, but we can go through it one step at a time. Twice the sum of the first 2. So the sum of the first 2 means we're going to have to add the first 2. So x plus 1. Okay, so that's the first is x. And then the second one is x plus 1. Okay, but it's twice the sum of the first 2. So we got 2 different things going on here. So we need to multiply whatever that is times 2. Twice this is 2 less than. So this, let's see, we're going to put an equal sign. We're going to worry about this 2 less than in just a minute. Now we got 3 times the third. The third is x plus 2, and we have 3 times the third. So we're going to have to multiply that by 3. Okay, now it's saying that this one is 2 less than this. So to make those equal, we're going to have to add 2 over here or subtract 2 over here. I'm going to subtract 2 over there. It's 2 less. So this side is 2 less than this side. Now they're equal. Okay, now we just got to rainbow all this out. X times 2 is 2x. 2 times x is another 2x. And then 2 times 1 is 2. Now this one, 3 times x is 3x. 3 times 2 is 6 minus 2. Okay, so I just rainbowed everything. All right, now we're going to combine like terms. 2x and 2x will be 4x plus 2 equals 3x. And then we got 6 minus 2 is 4. All right, now we got to put our like terms together here. So let's get all our x's on one side. And we're going to get 4x minus 3x is just x, plus 2 equals 4. Now we're going to do minus 2. And we get x equals 2. Okay, so that's not the answer. That's our first integer is going to be 2. Our second integer would be 2 plus 1, so 3. And our third integer would be 2 plus 2, 4. So the answer would be 2, 3, 4. Okay, another example. And in the book, they're using n. I've been using x. Either one works fine. All right. Find 4 consecutive integers such that 6 times the sum of the first and the fourth is 26 less than 10 times the third. I'm going to write all that out so we can see it. So it says 4 consecutive integers such that 6 times the sum of the first and the fourth and the fourth is 26 less than 10 times the third. Is 26 less than 10 times the third. Okay, and we got to find 4 consecutive integers. So we're going to have the first, second, third, and the fourth. Okay, the first we're going to name x. Then we're going to have x plus 1. The third will be x plus 2. And the fourth will be x plus 3. Okay. All right. So 6 times the sum of the first and the fourth. 26 less. 10 times the third. Okay. So we've got several different things in our equation here. All right. So first we're going to need the sum of the first and the fourth. The first is x. The fourth is x plus 3. Okay, and we need that 6 times whatever that is. So we're going to put that in parentheses and multiply it times 6. Is 26 less than 10 times the third? Okay, so we're going to put an equal sign. 26 less than 10 times the third. The third is x plus 2. And we have to multiply that times 10. 10 times the third. Here's the third. And it's saying that 6 times the sum of the first and the fourth, this part, is 26 less than this part. So if we minus 26 over here, then our equation will be balanced. We could either add 26 on this side or subtract it on that side. Okay, now we just have to work all that out. So 6 times x is 6x, and then 6 times x again is another 6x. Right there. And then 6 times 3 is 18 equals. Then we got to do 10 times x will be 10x. 10 times 2 is 20. And then minus 26. Now we got to combine our like terms. 6 and 6 is 12. X plus 18 equals 10x minus 6. Positive 20, negative 26, negative 6. All right. Now we're going to put our x's together. And we end up with 2x plus 18 equals negative 6. I'm running out of room here. I'm going to move this up to the top. Okay, so I've got 2x plus 18 equals negative 6. So now I'm going to do minus 18 minus 18. And I get 2x equals, I owe $6 and I owe $18. 6 and 8 is 14, 20, negative 24. Now I just have to divide by 2. And I get x equals negative 12. Okay, negative 12 is not our answer. That's just our first consecutive integer. So if our first consecutive integer is negative 12, x equals negative 12. Then negative 12 plus 1 would be negative 11. Negative 12 plus 2 would be negative 10. And negative 12 plus 3 would be negative 9. So there are our consecutive integers, 4 of them, that satisfy that equation. All right. Go ahead and pause the video and do the practice problems, and I will come back and work them for you. Okay, these are the practice problems for lesson 76. Okay, so the first one, A, says, find 3 consecutive integers such that the sum of the first and the third is 142. All right, so 3 consecutive integers. We're going to have the first one, the second one, and the third one. And the first is going to be named x, the second is going to be x plus 1, and the third is going to be x plus 2. All right, so it says find 3 consecutive integers such that the sum of the first and the third is 142. So the first is x, and the third is x plus 2. First, third is, so the sum of the first and the third, means we had to add those two together, is 142. Okay, so we're going to add like terms first. We get 2x plus 2 equals 142. Now we subtract 2 on both sides. And we get 2x equals 140. Now we divide by 2. And we should get x equals 70. Double check that. Okay, that's not our answer. That just tells us what x is. So if x equals 70, that's our first integer. Now we need x plus 1, so 71, and then we need x plus 2, so 72. So 70, 71, 72. That's the answer to A. All right, B. Find 4 consecutive integers such that 8 times the sum of the first and third is 40 greater than 10 times the fourth. All right, so we're going to have first, second, third, and fourth. X plus 1, x plus 2, x plus 3. Okay. 4 consecutive integers such that 8 times the sum of the first and the third. So we're going to do that first. 8 times the sum of the first and the third. Sum of the first would be x, and the third would be x plus 2. So there's the sum, x plus 2. So there's the sum of the first right there, and the third right there. And there's the third. X plus 2. Okay, so it said 8 times the sum of the first and the third, so we got to multiply all that by 8, is 40 greater than 10 times the fourth. I'm just going to go ahead and put my equal sign, and I'm going to say 10 times the fourth. So 10 times the fourth is x plus 3. Now we got to figure out where that 40 goes. So it says that this side, the sum of the first and the third times 8, is 40 more than this side. So to fix that, we can add 40 over here. This is 40 greater than this, so we added the 40 on this side to make those even. All right, now we're just going to rainbow this out. And then 8 times 2 is 16. And then 10 times x is 10x. 10 times 3 is 30. And then 40 over here. Okay, now we're going to add like terms. 16x plus 16 equals 10x plus 70. Now we're going to get our x's together. And we get 6x plus 16 equals 70. Now we're going to subtract 16. We get 6x equals 6 is 4, 6, 54. And then that will be 6 times 9 is 54. All right. Yep, 10 times 9 is 54, so x equals 9. All right, that is not the answer. That just tells us what x is. So then if we erase all this, okay, that tells us that up here, that x is 9. 9 plus 1 would be 10. 9 plus 2 would be 11. 9 plus 3 would be 12. So the answer is 9, 10, 11, 12. 4 consecutive integers. So remember, you're not only just finding x, you have to find the other integers that go along with x. All right, that's it for lesson 76. Your homework is lesson 76. Sorry I was late on these videos. I had to go back to work at O'Charlie's. I will try to post another video soon. And if you have any homework you want to turn in, just send it to me. Thanks. Bye.